Changes in the position of only one substituent can lead to inactive isomers. So what this says is I don't even have to add or subtract anything from this. This is a progesterone molecule. If I just change the position, so let's say that these open circles are, if you look at it 3D, is coming outside the screen. So what that means is that if I push those from being outside the screen and push them into the same plane as the screen, I have changed the position, and therefore I could have an inactive isomer. I would definitely have a different compound just by changing the position. Now, this is Provera and this is progesterone. Now, when I talk to lay people, in order to become an honorary gynecologist, they have to pass a board exam. And this is the one and only question of the board exam. And if they pass this, they are honorary gynecologists. If they know that estrogen stimulates growth and progesterone stimulates development, and if they can answer this question, does this look different than that? I've had a 100% pass rate with lay people. You go to an ACOG meeting or North American Menopause Society meeting, they will line up speakers to get up and try and convince you that these are the exact same molecules. Am I right or am I wrong, OBGYN? They will parade speakers one after another and say these are the exact same compounds. And Spiroff says all you got to do is change the position and you got a problem. They adding acetate groups and all other things. Okay? So let's look at this even in more detail. This is progesterone. This is the steroidogenic pathway. And they have enzymes that are involved in reconfiguring these molecules. It's two enzymes. Enzyme number 5, which is 21-hydroxylase, puts a hydroxy group at the 21 carbon. And that allows it to go toward mineralocorticoids. It also has another enzyme, enzyme number 3. Enzyme number 3 has 17 alpha hydroxylase. 17 alpha hydroxylase puts a hydroxy group at the 17 position. There's only two enzymes that can work with progesterone, 21-hydroxylase and 17-alpha hydroxylase. So let's look at this. This is Provera. That's the 17 position. At the 17 position, you have an acetate. In order for 17-alpha hydroxylase to be able to put a hydroxy group there, you would have to have a 17-alpha acetatase, right? In that list, do you see 17-alpha acetatase? Why not? Your body said, what you go put an acetate group there for in the first place? So who told you to do that? See, whoever came up with Provera, I forgot the name now, we didn't want to give them the recognition. They forgot to call God and say, can you put a 17-alpha acetatase in there so my Provera will work like that progesterone stuff? Okay, so we got a problem biochemically. All right? Now, let's look at this. Oh, I want to go back to this. My thing's not working. Okay, let me ask you this. If I put something that is identical to progesterone in this system, what's going to happen to it?
It'll function. It'll function.
Either it's going to get a hydroxy group at the 21 position, or it's going to get a hydroxy group at the 17 position. If I put something that's identical to it. If I put Provera in there, what's going to happen to it?
There's nothing in the book.
Who knows? That's why you got to have a 20-year study to figure it out. I mean, I'm just being honest with you. Who knows? You don't know what it's going to do with that acetate because your body is not able to, doesn't have the enzyme system, so it has to do something with it. That's why in the PDR, you got 2 pages of side effects because it'll do different things according to what enzyme systems you might have. So you got to have double-blind placebo-controlled studies for that. But if I'm putting something identical in there, I know the pathways it's going to go, and if I can check for those metabolites or those byproducts, I can know exactly what it's doing with it. Correct? Okay. Now, if you don't think a small change makes a big difference, let me just show you something. Those are bioidentical hormones. You see how they've got double bonds and single bonds with methyl groups on them? All double bonds here, okay? And if you look at that steroid pathway, there's nothing higher than a double bond anywhere, okay? Now these are not bioidentical. Look at these triple bonds, and what you call, I'm not a chemist, what is this thing up here? I don't even know what it is, but I know it's not in that other picture I showed you. So what's your body going to do with that? How is it going to break down that triple bond? Huh? I don't know. There you go. I don't know.